Please, everyone, let's welcome our panelists, and if you can go back to your seats, that would be great. Okay, thank you all for being here. We have amazing panelists today, and I'm gonna start from Thomas. We're in Massachusetts. This is the land of the Massachusett. So Thomas Green is a Tribal Councilmember for the Massachusett tribe at Ponkapoag, chairman of the tribe's History Preservation Committee. He's a cultural interpreter and an Indigenous artist. He has dedicated 30 plus years to researching the Indigenous history of Massachusetts. Thank you for being here. Louvere Walker-Hannon is a MathWorks application engineering senior team lead who manages a team of application engineers and provides technical guidance on the implementation of AI and data science workflows for various applications. She has worked in 3 different engineering roles throughout her 20-plus year career while at MathWorks. She's an active STEM advocate who volunteers with a variety of organizations, presents at numerous STEM-related conferences, and is a recipient of several accolades connected to her STEM advocacy. Thank you for being here.
Thank you.
Then we have Ken Sebesta. Before joining BU, Ken Sebesta co-founded an autopilot ecosystem, raised millions of dollars in venture capital for drones, and directed worldwide hardware development and deployment at an MIT Smart City spin-off. Now he's focusing on building the next generation of applied roboticists. And if you haven't been, the Rustic labs here at BU are truly impressive. Thank you for being here.
Thank you.
And then we have Dr. Felici, who has been a dripper since 1974, leading work in guidance, navigation and control and system engineering for launch, space, lunar landing, planetary landing, hypersonic, missile defense, and airdrop vehicles. He served 4 years on the Air Force Scientific Advisory Board. He is a fellow of the American Institute of Aeronautics and Astronautics, and has been a lifelong student of space exploration history. So thank you all for joining us today. Because I never led a panel before, I'm gonna start my way asking a round of questions to each of you, and then we're going to open to Q&A. And as before, please wait for the microphone or walk to a microphone or use the Q&A feature on Zoom. So I'm gonna start from Thomas. Indigenous people are the earth wisdom. So what can we learn from the earth and from Indigenous connection with the earth? And considering that we are using the word colonizing once again and as building to horror in the past, how can we colonize and bring life instead of what we didn't bring before, aside from destruction?
So the earth will provide and sustain anything living upon it responsibly. Indigenous populations have sincere concern and sense of responsibility towards their ancestral lands, waters, and life in general. Indigenous populations have learned to take only what they need from the land in order to ensure the longevity of life-sustaining resources, which is to ensure the longevity of all the species that utilize them for survival. We are the only species on this planet cognitive enough to understand the complex and intertwined and reciprocal relationships between the myriad of species occupying the planet and the planet itself. Therefore, if we as a species see something wrong and have the ability to make it right, we have the inherent responsibility to make it right, especially if it is something wrong or off balance due to human activity. And I think the thing to take away is that mankind is meant to steward the earth to ensure the longevity of all life created and supported by this planet. And she is the mother of us all and the mother of all life as we know it. And she deserves our utmost respect and reverence.
Thank you. So going to ask the second question to Louvere. Lou. So what is the potential of AI and in relation in general and in a connection with space exploration? And is it accessible to everybody, or is still segregated in a way? And I know you have prepared a presentation for us.
Certainly. So thank you, Marianna, for your questions. I heard two questions, actually, versus one. So for the first part of the question related to, what's the potential for AI in general? So AI is impacting every single one of our lives. Would you say that's correct? Yeah, exactly. So we're seeing it, for example, in our smartphones. We're seeing this, for example, related to healthcare and so many other areas. So there's a large amount of potential to assist human beings in a variety of ways. So one of the ways that AI can help is related to maternal health, because there is a humongous issue, not just in the United States, but also worldwide, related to maternal health. And one of the issues is after a pregnant person leaves a hospital setting, there are a lot of times where there are health complications. And how can individuals pretty much be monitored to see how they're doing after giving birth and being able to get additional care? So that's one area where AI could be helpful. Now, the second part of the question that I heard was, is AI accessible to all? So I have to admit that is a very interesting question, because at a very high level, a lot of people do have access, but I'm going to spin that to say, is everyone taking a part in the development of AI? Is everyone taking a part in providing feedback that's impacting their communities? I would say no. So a lot of people have access, but by the same token, a lot of people are not providing feedback and I say very helpful insight into AI and how it's being used and how it's being implemented. I hope that helps.
It does. Would you like me to go through your slides as well, or are you fine as is?
Whatever works for you, Marianna. I'm fine.
Thank you. Thank you. I'm going to ask the third question to Ken. What are possible synergies between AI and robotics and space exploration? And if you would like me to project your slides, because I know you.
I'm fine without the slides.
Okay.
I'll just follow the trend. So robotics and AI and spacecraft, this is a fascinating question. We start off by even asking what is AI and what are robotics. Those of a certain age would remember that a washing machine used to just be a dumb machine. You turned a dial and it ran for a certain amount of time. The bell chimed, the load of dishes was clean. Now we have robotic washing machines. What do they look like? They don't look like robots with robotic manipulators, but I guarantee you on the inside they have the smarts and the intelligence that separates them from being a dumb machine and makes them something smart. So as we hurtle off across the space above us, what do we expect from robotics? What do we want? I can speak from a certain perspective. I'm a pilot. I do fly airplanes, and I make flying machines. So my handle on Twitter, or what used to be Twitter, I guess, is aeroboticist. This stuff fascinates me, and so I can speak from a certain understanding what I might appreciate if I were to be the person inside of the metal or stainless steel box headed off toward Mars. I don't think of robots as doing these jobs for us. I think of robots as being my first mate, as being someone who can tap me on the shoulder and say, hey, that didn't sound quite right. And that lets me connect the analog to the digital. It lets me, who has the ability to move complicated manipulators and think up new strategies and solve new problems. That lets me take in information which I might not have noticed without the enhancement of machine learning, of artificial intelligence. I might want artificial intelligence to say, hey, did you know that in about 5 minutes you're going to want to switch a fuel tank or monitor a device or send a message? I would want AI to supplement my ability in the same way their first mate would by saying, let me take care of these secondary, these important tasks, while you take care of the urgent tasks. I would want AI to perform the fast level reactions, which I can't do. The ability to dock a spacecraft is something that humans probably have very little business doing. because the machine can do it much better. But the ability for me to decide when is the right moment to go for this, when the craft is ready, when the crew is ready. This isn't a decision that AI can make because AI hasn't seen these problems before. We call it AI, but again, it's not true artificial intelligence, it's machine learning, and it can only learn what we've taught it. It can only learn the things we've thought to taught it within the bounds of the complexity of the models that we create. And so while I absolutely need that first mate, I absolutely need that ability to oversee parts of the trajectory, I need the ultimate authority over where this is going and what we're going to do when we get there. And these things we have to innovate, we have to invent, and this is not a strong suit for machine learning.
Thank you. And my fourth question is to Phil. So now we put all of these items together. So we packed our suitcase, we have the plants, we have the microbes, we have the connection with the planet. How do we get to Mars, and what are the challenges? And can we get there without catching on fire and crashing on landing?
All right, well, I'll answer that with a couple of parts. First, how we get there is we're not just going to, with Apollo, we launched one rocket and we went to the moon with 2 spacecraft, the one that landed on the moon, the one that orbited the moon and brought the crew back to Earth. They did rendezvous in lunar orbit and they came back to Earth. We aren't going to be able to do that for Mars. We're not planning to do that for when we return to the moon. We're going to be assembling spacecraft in orbit. We're going to be with multiple launch vehicles taking up propellant or fuel, for liquid propellant, which is probably the way we're going to go to the moon in the foreseeable future. But nuclear propulsion is going to be developed and it may be used go to Mars, but you still need hydrogen or some other fuel that will be heated by reactor with, to get much more efficient propulsion than with a chemical, but still need fuel and a lot of it. So there's going to be this complicated process of assembling space and maybe manufacturing some of the components in space, and the difficulty of transferring cryogenic fluids in space, much more complicated than it sounds because of heat transfer problems. Then there's the problem of getting there. You've got the spacecraft. If you use conventional chemical propulsion, you're probably going to be spending the better part of 2 years going to and from with some months at Mars. If you get nuclear propulsion, you might be spending a few months going there and coming back. But you're going to be flying through an environment outside of the Earth's magnetic fields. So in addition to the solar proton radiation that was discussed in the presentation earlier today, you got the galactic cosmic rays. There's a big difference between the two. Solar storms produce a lot of energetic protons. You can take your water tanks in the spacecraft, create a storm cellar where the water tanks are around you, and they'll protect you from the protons if you've predicted that they're coming, and they won't kill you that way. Galactic cosmic rays are much too energetic to be able to do that. And if we spend 2 years in space, something like 0.5% of your neural cells will probably be killed by the galactic cosmic radiation. We do not know what the cognitive effects on humans will be. Now, there are technologies that could mitigate that somewhat. If we have about 5 megawatts of power in a spacecraft, we can create magnetic fields that can probably be used to deflect enough of the galactic cosmic radiation that you reduce the exposure of the crew by 20 to 30%. That's a big deal when you're talking about these levels of exposure. But you need to be able to generate that power with sufficiently low mass to go on a spacecraft. So there's these issues: assembly, propellant transfer, radiation, all these things we have to deal with, and that's even before we land on Mars.
Yes, that's the catching on fire and crashing on landing part.
Yeah, and I'll just we can talk more about this later, but landing on Mars, you're probably going to pre-position supplies. You have to be able to land in the same spot where they are. Landing exactly where you want on Mars is hard to do. All those things about the variable atmosphere they talked about before, that affects how you enter and how you steer. And because the atmosphere is thin, you cannot do a whole lot of steering. So that's the other challenge, is getting to exactly where you want on the surface.
Thank you. It doesn't sound like going, it's a good idea. Just
Well, I think it's a terrific idea, but it's hard. And it's not that different from Kennedy said in 1962. We do these things not because they are hard.
yes.
And what we get out of them, you know, the new capabilities we get out of doing hard things are far more consequential in the long term than doing something we're already close to being able to know how to do.
Very true. Very true. So we can open to questions from the audience and from Zoom. But if you're feeling shy, I have a second round because I have a lot of questions in life. So, is anyone? Okay.
Okay, have any of you seen UFOs, and have you asked them how to do this? I know somebody's dying to ask that. You were expecting that question, I know.
Oh, geez. Well, all I can say is, you know, at least the government is discussing this in the open now. You know, we had these, used to be treated like you were crazy, and now, you know, NASA and other agencies officially are talking about these strange observations. But there's been a lot of strange observations. When they really get down to the business of studying them carefully, 70, 80, 90% of them can be explained away. And it's those other 10, 20%, whatever they are, you know, and we just don't know. We see phenomena going on that are not easily understood by projecting technology as we see it now. Now, they can't rule out the fact that we have an adversary out there that's exceedingly capable. You know, somebody, you know, you take the scenario of 20,000 leagues under the sea, and in the 19th century, somebody's got a nuclear submarine. So what would somebody unfamiliar with nuclear technology at the time have thought about that? Well, that would seem like an alien technology. So it's possible there's some very capable adversary on Earth that's doing these things. Otherwise, we just don't know. And is it a physical phenomena that hasn't been observed, or is it aliens? You know, your speculation is as good as mine. And I think the universe is vast. There's all kinds of things going on. There's all kinds of possibilities. But then there's also the Fermi question, which is, if the aliens have been to Earth, how come we haven't seen them?
No, I have to admit, I work for, over the years in my roles, I've worked with a number of government entities, but I have not seen any of those items myself. I know that sounded really convincing.
I'm not sure if this helps, but as a historian, every ancient civilization carved in stone that beings came from the sky. And again, in my opinion, misunderstood technology. These weren't gods. These were, but I mean, you know, the ancients, they carved this stuff into stone. So again, and I'm not an archaeologist, I'm a historian, but I tend to believe, I'm not sure if anybody here has ever tried to carve anything in stone. Today we have a lot more advanced tools to do that with than ancients did, so it must have been a lot harder for them to do it. But every single ancient civilization said that beings came from the sky. So I'm not sure if that counts as an answer to your question. I personally, I wish I had some kind of an experience. I have not, but as a historian, I can say that every ancient civilization said that beings came from the sky.
Have we answered your question? Oh, sorry.
So, speaking of history, what lessons should we take from the past when we're looking into this future, especially as it regards to colonization and space travel? What lessons should we learn and keep in our minds as we move forward?
We're not ready. We do not have a sincere appreciation for what we have here on this planet, including our own lives, the lives of our own species, never mind the species we believe to be, that we have subjugated and dominated. We don't even have a good enough understanding of most of the things we've already destroyed here, that are gone, that we won't have an understanding of because our ignorance. destroyed it. And, you know, not just talking about, you know, animals, but plant life. I just don't think that we are responsible enough species. We haven't learned how to be good stewards to the planet that sustains the very life we use, the very breath that we, you know, use to sustain our own lives. We don't appreciate that. So it does not carry a lot of weight with me when any human being says that we can travel responsibly among the stars. We'll probably kill ourselves and do away with a lot of other things that life that we just don't understand. It's not even something we do on purpose. We just don't recognize it as life because we're not there yet. I just don't believe we're responsible enough to try and colonize the stars. Maybe to go check out our satellite, the moon, utilize that to our advantage. That might be a good first step, but I'm not sure about colonizing other planets. We haven't been very responsible with the one we have now.
Well, I'll take a slightly different tack than that, and I'm certainly not going to disagree with how human nature has contributed to so many problems that we experience today. I view space exploration as an opportunity for more collaboration. I think one of the geopolitical lessons from Apollo is going into a space race purely for a competition between superpowers is not a sustainable enterprise. Apollo was very successful, and it ended almost as soon as it achieved success. And here we are, 52 years after the last lunar landing, still trying to prepare to do it again when it took us less than 10 years to do it the first time. So in contrast, the International Space Station has been a very successful enterprise with many nations, and despite the incredible disagreements we have with Russia today, we've managed somehow to maintain the collaboration on the space station to this day. Now, maybe that'll end in a few years after the current agreements expire, but I've had a couple of my students who have become astronauts, one of which who spent 6 months up there, including with the Russians. And the thing is, there is an incredible camaraderie among them up there because they know their survival depends on each other, and their national disagreements aren't going to help them. So there's an opportunity to leverage space exploration to try to mitigate some of our adversarial behavior and chasing after something bigger than the rest of us. But we cannot ignore what was said before about addressing those serious problems we have here too. So doing this enterprise cannot be at the expense of addressing the problems on Earth, but has to be, a part of a more comprehensive solution to our problems.
We have a question from online, from Sonam. We live in an age of information overload. What strategies do you suggest for staying updated with relevant AI information? Additionally, do you believe AI cloning will benefit the space industry?
Is there a definition of AI cloning in this perspective?
No.
Good luck. Can we ask them to clarify?
I believe you just did.
Oh.
We'll see if we get a response. But if you feel like answering the first part of the question, we can go with that.
No.
We're going to look at each other. Okay. So the first part of the question I think I understood was, how can we stay up to date with the latest information related to AI? So I think there are a lot of different resources. I mean, one of the biggest items for me is trying to understand, maybe at a level for that individual, what makes sense for that individual. For example, for me, I read a lot of papers and a lot of articles and textbooks. But you want to also be dynamic where are there websites, are there podcasts and other resources that could also help out as well. But I think one of the biggest items for me is for a lot of the customers I work with related to understanding, okay, what's new and what's different in AI, I typically try to meet them where they are and see what works best for their learning styles, what also works best in terms of their resources. For a lot of them, it is reading a lot of research papers based on their work. So a lot of them are using IEEE repositories and a few other related resources.
Thank you.
With regard to the UFO question, I had the pleasure of serving on the NASA UAP panel, and I can say definitively, amongst all of the data that we looked at, whenever there's an extraordinary claim, there's insufficient data to be conclusive. And whenever there's sufficient data, there's an ordinary explanation. Yeah, I don't know if you want to comment on that, but I did have another question.
I'm reminded of what happened after the Viking landings and the rather unusual life search results. In several respects, the experiments on Viking, Viking was from 1976, was a long time ago already, to mimic the behavior they would have expected, where there was a rapid consumption of organic fluids that were put in there and the generation of what could be perceived to be some respiration products and all that. But they didn't have all the pieces. So all these years later, we're saying we do not have sufficient evidence to claim that there was evidence of life there. We've been doing a lot of experiments since. We have not duplicated those experiments. We've been doing other things, and there's interesting results, and there's certainly evidence in the environment of Mars that there could have been life in the past. We now know that we have meteoroids that have landed on the Earth that came from Mars. The chemistry we've done on Mars has proven that those are from Mars. It's a very small percentage, but even some people think maybe life formed on Mars in microbial form and came to Earth that way. But nobody in a position of scientific authority has been willing to accept that result yet, because again, extraordinary claims need extraordinary evidence. So I don't know if the UFO or UAP or whatever we want to call these things these days is in the same category or not, but there certainly have been a few sightings, particularly the ones by Navy pilots, that are really interesting in terms of what is it they're observing that can be changing orientation so fast, going from the sky to the water and back into the sky. I mean, we just don't know the answers to that question, but claiming it's aliens would be beyond what we know.
If it's okay, I'm really curious about this galactic cosmic ray problem. Is this the fundamental obstacle to space travel? I mean, you talk about, did you say 20% of my neurons will die if I go to Mars?
No.
That happened at the party last night.
0.5%. In a 2-year mission, 0.5% of your neurons.
And I was just wondering if, AI, collaboration with AI could fill in those neurons. Maybe there's something outside the box that we need to
I don't know. I mean, obviously, one of the mitigation factors, nuclear propulsion that can take you to Mars, maybe in 60 days and bring you back to Earth and something like that would mitigate that problem. You still have the problem on Mars that you can't be out exposed. Mars doesn't have the magnetic fields like the Earth does, so the cosmic rays don't all go to the poles. So the people on the outside are going to continue to be exposed to them, but you can live under the surface, under the regolith. You can use tons and tons of stuff when you're on the surface that you can't use on a spacecraft. So the real problem is the time going back and forth. And, if you could produce hundreds of megawatts of power on a spacecraft, you could probably eliminate most of the, strong enough magnetic fields to drive them away, but you can't. But 20 or 30% reduction, when you talk about these kind of exposure effects, that's consequential. And it's really a question, what risks are humans willing to take? Now, one thing that, I had a few slides in the packet, but one of the things we talk about, there's a station called Gateway, which NASA's planning to put into a halo orbit around the moon, and the future lunar landing missions would go through that. And you could put crews there for periods of time and explore 3 months, 6 months, 1 year, what that does to them. You know, they'd be human guinea pigs by doing that, but, you know, be operating 250,000 miles from Earth, and that would, a lot of people would be willing to do that. But, you know, but you don't have to go to Mars first to figure out what that kind of exposure was. You can do something closer to Earth to do. You can't do it on the space station because you're still within the Van Allen belt, so it's got to be out, it's got to be in cislunar space rather than near the Earth.
One thing that I don't know if I heard today that would be an impediment to humans settling elsewhere is the fact that we are intimately tied to the very chemical composition of our planet. There is just the right amount of iron in my body. Too little, too much, and I'll die. There's just the right amount of lead in my body, and it's problematic. Consider that any other rocky planet or planetoid is going to have a different composition of trace minerals. And so if your idea is that we can terraform this and somehow go and live and eat some kind of self-sustaining food through that very soil, there are some very hard problems to solve there that we don't even know how to think about addressing those questions. So why are we going to Mars? Is it to go to Mars purely because the problem is hard, but then we wind up with an Apollo situation where we went there, and now what? The nature of robotics and automation has made it so that this kind of spaceflight is no longer purely the domain of nation states, but now it's basically deranged billionaire money, and soon enough it might be deranged 100-millionaire money. And so we might see people who take it upon themselves to do it. And I could certainly understand the drive to be the first person to Mars, even if it were a one-way trip, if you could simply raise that amount of money. But that's a very different question from your question, which is now what? Once we get there, and we do want to think about the long-term impacts, let's say that we could grow food on Mars, how is that food going to affect our bodies? Could we potentially consume it? Or would we get either starvation of nutrients or worse, metal poisoning?
We do have a clarifying on AI cloning. AI cloning in the space industry involves creating advanced artificial intelligence systems that can replicate the functions and decision-making abilities of human experts.
I don't see the difference between that and between normal generative AI. I might be missing a nuance, but that is what machine learning generative AI does. It looks at the past and it tries to make a guess at our future based on past patterns. And to be honest, that's what engineers do. That's what we do. We try and make estimates of the future that are so good that we're willing to risk our very lives. I'm sitting here on the 17th floor of a building that I hope to dear God will not collapse under my feet. And I believe it won't, and I'm willing to take that risk with my life because I'm so sure of the math. And so generative AI is building on that kind of basis. It takes the collective work of all of humanity and tries to guess what happens next. But I don't see how that is different in applied to space, aside from the fact that space generally has much, much, much nicer math. It's a lot easier to predict when there's, a lot easier to predict dynamics and kinematics when there's no friction.
So if we talk about like ChatIBT, we went through, I helped to develop the shuttle flight control system. So we did a little experiment, a few of my colleagues and mine a few months ago. First of all, asking Chat to give us some facts about the design of the orbit flight control system, the deadbands, the rate limits, some of the other features. And of course, it gave us a very detailed answer with references. Well, the answers were wrong. And the references, at least one of them, didn't exist. Now, why is that? Well, these are learning from data that's collected not in a particularly well-controlled manner. And so it takes in lots of data which may be wrong. It may even take in claimed references about things that don't exist, and it doesn't differentiate. And then when you ask it to spit that out, if you're not an expert to sift through that material, you might get stuff that is, garbage in, garbage out on a very sophisticated level. And that's my biggest concern about this is what is it learning from? And then some people, there's the ethics of what it's learning from. Is it learning from people that are actually giving it permission to learn that about them? There's the ethical questions, the accuracy questions, all these things that we as a society have not worked through.
I have 2 questions. Sorry, I'm gonna take my power of moderator and ask 2 questions. One is to reconnect to why do we go there, right? And if it's as we colonize thus far, we're squandering whatever is there, so we're just mining. And for that, I wanted to ask you, do you think the human species can colonize bringing life rather than destruction? And my second question is for Lou, reconnecting, before I forget, reconnecting to what you were saying about AI not being accessible, or these tools not being accessible to everybody. If I think of my field is very white, what are we doing wrong? So.
I think really the best way to answer that question is just to reiterate what I said earlier. We have to sincerely learn how to appreciate what we have here. I mean, we can say that we appreciate the air that we breathe, but in my opinion, no one really appreciates the air that they breathe until they have some kind of pulmonary issues. When you can't get that air, then you appreciate it. When you don't have any of the things that you need to survive, that's when you appreciate it. But we have that stuff here, and we very clearly take advantage of it. We are, making the air unbreathable, the water undrinkable. We have multi-million-dollar corporate conglomerates that are making the food uneatable, and the FDA authorizes them to do that. So, I mean, what are we taking with us to sustain us on Mars? And if we go there, are we going to just start exploiting? I mean, and that's another question. Why? Why are we going to Mars? Is it just, again, because we can? And is that a good enough reason? And I think that that's one of the biggest questions we need to answer as a species. Because as a species, and I can say this from a historical point of view, we as humans squander what we have as a species. We think that there is an unending supply, an unlimited supply of every resource, and more so with Americans. So I think we're going to have to change we're going to have to change our mindset. We're going to have to change the way that we think about resources and each other, and our relationship with our resources and with each other and with the planet. Are we going to this planet to benefit the planet, or are we going to the planet to benefit ourselves? And I think that every relationship, and I'm sure that most people would agree that any healthy relationship has to be reciprocal. And that's just not between human beings, it's with human beings. And if you have a pet, if you ignore that pet, eventually that pet's going to get sick of you and run away. You have a child and ignore that child. You have to have reciprocal benefits. So I think that instead of really only thinking what can we gain as a species from going out into space and colonizing, and this goes back to why the indigenous people here on the East Coast found themselves in so much trouble. The current dominant culture gauges wealth by what you can have and what you can acquire and keep to yourself, where the indigenous culture recognizes wealth as how much you have to give selflessly of yourself and how much you do give selflessly of yourself. So are we going to another planet simply to take, to benefit ourselves, or are we going there to try and do something that might also benefit that planet? And do we know enough about that planet to be able to tell the difference between either? No. We don't know enough about our own planet to be able to differentiate that. So I hope that helps.
Thank you.
And then related to the question that had a connection with, I'm going to rephrase it as representation in various fields. So fields related to, it's not just space exploration, but, you know, AI, STEM, and STEAM overall. So one of the items that I've observed over the years is, yes, there are a number of outreach programs and initiatives to make certain there's representation from a variety of groups. But it's not just about those outreach programs. It's about once you're in certain environments, are those individuals able to thrive? Are those individuals able to highlight, you know what, when someone was taking this collection of data to help train, let's say, a neural network to give us some sort of classification in terms of some sort of output, you know, if someone from, I'm going to say, a variety of backgrounds does question what was being done in terms of that process, is that representative of a certain population, or does this make sense? Hopefully people are in environments where they're able to ask those questions. They're able to get support to highlight, you know what, that's a good point. Maybe we need to revisit. Maybe we need to rethink that. One of the biggest items that I have to admit I've seen and in some cases experienced is, you know, for a variety of reasons, someone may not take that feedback into account. We have to question why. Is it because of my physical appearance? Is it because of my degree? Is it because of my background or something else? I think that needs to be explored. I think we need to keep that in mind. I think we need, each of us, whether in this room or beyond, need to, you know, take a step back and reflect. Because in the meantime, a lot of people are not able to provide their feedback and their voices and experiences to help assist with a variety of different types of problem solving.
Thank you. In a way, sorry, I just want to follow up a little bit. How can we make it better, though? So what's the, I know you work with NSP, for example. So do we connect with people like you, for example, during an hiring process, when we advertise a position? Is it the way we formulate the advertisement, or what is it?
Okay, so I have to admit, that is a very loaded question. It's
Sorry.
almost as if asking, you know, how does one solve a variety of isms and phobias and so many other things? But I'll try to say at a very high level. So Marianna mentioned, you know, one organization I volunteer with. So NSBE, the National Society of Black Engineers. There's a Boston Professionals chapter. BU has a collegiate chapter. There are many other chapters that exist. You know, the question is, do we connect with those organizations or similar organizations to help with trying to find that pathway? I think that's one part of the answer. But once people are able to get into a variety of organizations, what does the culture look like and feel like in those organizations? Are those organizations ready, able, and willing to have a culture where, you know, everyone is going to have a say, everyone is listened to? You have people where, you know, there are projects that are being worked on. Is it the same 5 people? Why is it the same 5 people? What's happening there? So I think that, yes, one part of it is trying to connect with a variety of organizations, but there's also another piece where once someone is in an organization, what is the culture of that organization? And how can that culture either, you know, maybe evolve, or in some cases, does that culture already exist?
Thank you. That is complicated. Yes. Other questions from the audience and from home?
I've been wondering, how influential do you think the private sector is going to be?
In space exploration?
Yes.
Oh, well, already enormously influential. You know, as a reference to billionaires going to Mars, well, of course, what's been driving Elon Musk for most of his time is getting humans to Mars, and he started SpaceX for that reason. He bought Tesla. He didn't actually start Tesla, so that wasn't attributable to that. But he has this vision of getting lots of people to Mars. Jeff Bezos with Blue Origin imagines sending 1 million people into space. I don't know that's going to happen in the near term, but when Jeff Bezos was asked what was his business plan for Blue Origin, his answer was, I sell $1 billion of Amazon stock each year. He doesn't care whether or not it makes money at this point. He's spending his money to do these things. Now, if you take SpaceX in particular, most of the launches in the United States today are on SpaceX rockets. Most of our national security missions are migrating over to that because they are providing most of the access and are less expensive. The more conventional rockets from a company called ULA, which Jeff Bezos may actually buy now, but was previously a Lockheed Martin Boeing joint venture. They still provide services, and the Department of Defense is still using them, but Elon Musk has taken over. There's actually raised some concerns, like these Starlink satellites. The Ukrainians have been using them to communicate in the battlefield. Well, early in the war, they lost some ground to the Russians because Elon Musk didn't particularly like what they were doing with it, so he turned it off over Ukraine. So this is a private sector individual controlling U.S. foreign policy. So it's not just that the private sector is selling lots of stuff to the government, but it's also directly influencing what we do. And there's the efficiencies that are resulting are of great consequence, but the challenges that the muscle that they exert over what gets done is a concern.
Without getting and building on that, because I think that's a great point, and it's worth mentioning that over half the satellites in orbit right now, I believe, are SpaceX satellites.
Oh, it's probably more than that. I mean, right now, I think it's already, about 8,000 or 9,000 of them that are
so
satellites.
The fact that one person controls over half of humanity's spacecraft is an interesting factoid. Make of that what you will, the separation between and the priorities of individuals versus governments. But I think it is a historical arc that when there is value, there will be people who will try to tap into that value. And we had a period where we didn't really understand what space was for. We knew we could get there, but aside from putting satellites into orbit and taking really good pictures of Cubans in Africa by seeing baseball diamonds, it wasn't a particularly useful strategy. It wasn't a particularly useful space, pardon the reuse of that word. Then GPS came along, and GPS was great for us pilots, but no one else. 20 years ago, when people told me GPS was going to transform the world, it's like, no, it's not. No one cares about GPS except people who want to get from A to B. Well, it turns out that imagine Craigslist without GPS. Imagine getting to a friend's house where you still had to look up directions on a paper map. So that alone has transformed the world in ways that we can't imagine. So when we have prices for getting to orbit where the cost of iteration is plummeting to effectively zero, on some scale effectively zero. I think I saw $100,000 was what the number was. Suddenly a year's salary in Boston can pay to put up a satellite. What does that mean? What kind of questions can I start answering? What kind of ways can I start exploring? Certainly this is not the domain of the government to explore and pick up every single rock and look underneath it and say, is there something here? So I think it is absolutely the domain of private sector. And as much as science fiction portends the future, all science fiction tends to generally be some kind of equivalent of a trucker moving through the galaxy and trying to pull along an old asteroid because they found the mother lode. They found $1 billion, $1 trillion in nickel, and they're just trying to get it back to the Earth. This motif shows up again and again and again. So I do strongly believe that's where we're headed.
I would just point out that, taking another area, the National Reconnaissance Office was a secret organization for many, many years, and their job was to develop satellites to spy on our adversaries with high resolution. And they developed some very clever but very difficult and expensive ways of doing that. And then they became public after, the agency itself, the existence of it became public knowledge, but what they do remains highly classified. But most of the high-resolution imaging of the Earth today is done by the private sector, not by NRO or its adversarial nation counterparts. And you can go buy a picture of almost anything on the Earth right now with a resolution of a meter or better. You want to see what's happening in your cornfield, you can buy that, but if you also want to see what's happening on the Iranian launch pad, you can buy that. You don't have to go through the US government anymore. Well, that creates some interesting things. It means the public can see things that they didn't see before, but also means that they can see some things that they really shouldn't see. And somebody can sell it to them or to anybody. And that, there's so many new complicated questions that result from that. And these are small sats that are doing the job. It's not, it's not 20,000 pound satellites, but it's the 500 pound, 200 pound satellites they're putting up that are doing that today.
Hello, thank you so much for this great conversations. So I have a question about what recommendations do you have for educating the public and not having maybe a fake lunar mission that people are still believing that the lunar mission was fake. So what do we need to do to educate the general public to understand this Mars exploration and space exploration? So thank you.
I think people respond principally to two things, narratives and value. And so part of the reason why they respond so well to we didn't land on the moon is because it's a fun narrative. And when it's a costless narrative for me to believe in landing on the moon or in Tony Stark as Iron Man, what does it matter? And that's where the value question comes in. So when you educate people, it helps if there's some value that education brings. You ask a great question. I don't have a great answer. It's something we struggle with. How do we live in a post-truth world? Because that's what generative AI does. Is it lets us present just as compelling evidence that we didn't do a thing, pick a thing, as that we did. And the way through that is through value. But inside the university, I know how to provide that value because I know how to tell my students, your grade is on the line. But outside the university, it gets to be a more pernicious question.
So I would just observe one other thing. Technology, as it advances, also tends to make it harder for some of those misinformation to sustain itself. As imaging becomes more and more capable, it's harder to avoid the evidence that you can actually see where we landed. You can see the tracks of the rovers on the moon. And if you have a good enough imagery, you can see the footprints. You can see the debris the astronauts left behind, including the backpacks that they wore. So it becomes harder and harder as years pass to deny that. And we also put more and more people, including rich people, going into space and taking their own pictures. And apparently within a few years, circumlunar around the moon is going to be one of the touring missions that you can take. But that, facts staring you in the face for some people doesn't seem to be good enough these days, does it? So I don't know how we solve that problem about human nature.
The other item, too, is in terms of educating the public. Once again, one of the themes that happens for me, for a lot of the volunteering I do, is trying to meet people where they are. So, for example, if you have people who are identified as being, I'm going to say, younger than probably many of us in this room, there are a variety of ways to be able to highlight to them this information. Now, going back to the topic of value, so that value is going to have a very different look and feel. So if you have, let's say, an elementary school aged series of individuals, the value may be, okay, just your awareness and, getting interested and excited versus, let's say, someone who is in high school right before they possibly graduate to go to college. The value is, this could be something related to maybe a potential career or field of study for you. So I definitely follow that idea of, meet people where they are with respect to education, whether it's space exploration or a variety of topics.
Knowledge is empowerment. That's the value right there. The more you know, the better off you are in general in life, and the better off you can make the lives and the standard of living of those around you.
Well, if there are no other questions, I would thank our speakers for the wonderful conversation. And we have a couple of slides from Ariri folks to show you how to connect with them, and for students, mentorship programs. I don't know if Ramfe is here. Oh, there you are. Sorry, I didn't see you. Would you like to come up real quick? You have prepared such beautiful slides. Going through them quickly. Yep, there you are. Okay. Would you like to come up real quick, and then I'm gonna.
Thank you for the invitations. This is my first time to involve in a speech or a program that's related to the astronomy. So it's really fascinating to me. So a brief introduction of myself. I am Ran Fei. I am the volunteers as the program coordinators of this data science mentoring circle programs. Our programs gathering groups of industrial professionals and who are willing to devote their times to help students develop their soft skills in data science area. So one of the issues of our program is that due to we only have quite a few mentors, so that means we have to refuse quite a few of candidates, students. So we have to say no to them. So I feel really sorry about that. So if you guys are really interested to be a mentors of a program, and if you guys have any candidates to recommend, feel free. I welcome you to connect with me, and let's work out together to give more students at BU an opportunity to learn the soft skills to help them launch their first job. Yeah, that will be all. Thank you.
Thank you so much, Ramfe. And there should be someone for the New England Research Cloud Alliance? Maybe not. I'm not an expert. This is like the Amazon cloud, but meant for researchers, so it's way cheaper. I don't work with them, so I don't know how to better explain it, but you can find all the information on the slide. Yes, so they offer a variety of services for a much lower cost if you are in a university system. So these are the closing remarks. So nothing can happen without a series of people who say yes. And none of this would have happened if the Ariri Institute didn't award us this grant, if astronomy, computer science, the College of Engineering, the Department of Earth and Environment didn't promote the event among their folks, if the panelists of the speakers didn't say yes to a crazy email saying, I'm doing a conference about colonizing Mars, do you want to come and speak for us? So thank you so much to everyone that was involved as a speaker of panelists today. And before we introduce the core engineering and science team, this is actually the whole team that went into this year-long project and in today's event. So thank you, everyone. A special thank you to Catherine, who couldn't be here today, but she's just wonderful and very supportive. So thank you all for joining us today. Now, this is I always wanted to do this. So please turn your name tags, and hopefully you fill them up with the kind of questions so that you can start chatting to people without awkward silences. And enjoy the view, the people, the food, and have fun. Thank you.